Uh, Quadratics, page 7. We're going to do a question for F. Use the vertex, axis of symmetry, and y-intercept to graph. Um, Remember that if they give you the equation in the form y equals x minus h squared plus k, that they're already giving you the vertex. Remember that it's minus h and plus k. That's kind of hard to remember. Okay. If you look at this equation, you can recognize that h is equal to, and this is negative 2, right? Because it's x minus h, and it's x plus 2, so that means x is negative 2. And here, you can see that k is equal to negative 3. So the vertex is negative 2 comma negative 3. So we already have the vertex. Axis of symmetry, if you have the vertex, is also very easy. The axis of symmetry is at the vertex, so we just take the x-coordinate of the vertex, and that's the equation for the axis of symmetry. Y-intercept, we simply put in x equals 0 into this, and we'll see what we get. So y equals negative 1/10. 0 plus 2 is 2 squared minus 3. So that gives us negative 0.4 minus 3, which is equal to negative 3.4. Okay, and now we're going to graph. We're going to graph this. So draw our axes there. And the axis of symmetry is this blue line here, x equals negative 2. And the other point we have is the vertex, which is negative 2 comma negative 3. It's right there. And we can see that the y-intercept is negative 3.4, which is just a little bit above, oh, I'm sorry, it's a little bit below that. It would be negative 3.4, so it would be just like right there. So especially since this a value is negative 1/10, 1/10 means it makes the parabola open very wide. So you can see it is very wide. It's so wide that I can hardly draw it well. So it's very wide. Okay, so this point here, the vertex is negative 2 comma negative 3, and then the y-intercept is 0 comma negative 3.4, so it's opening very wide. Now we're going to go down to 6a. Locate the turning point or vertex for each of the following quadratic functions. Now there's a couple ways we could do this. One would be that you could take, you could complete the square. And actually this one is, let's say, yeah, you could complete the square, and I'm just going to start that. I'm not going to do it all the way because you've already done many problems like that. But remember that to complete the square, you'd divide negative 4 by 2, and then you'd square it, so that would be negative 2 squared. So you want to add a plus 4 to complete the square. But then you have to subtract the 4 because you can't just add it out of nowhere. Okay, and then this would factor into x. This part would factor into x minus 2 squared, and that would be negative 4 plus 2, so minus 2. And so you already have it in the HK form, right? Except this would be a negative 2 would be k, and this would be 2. Okay. Another way you could do it would be to use negative b over 2a. So you say, yeah, the axis of symmetry is negative b over 2a. So that would be negative 4 over 2 times 1. So that would be like 4 over 2, which is 2. That'll give you the x-coordinate, and then you just put the 2 into there, and then you would get the y out, which would be negative 2 also. I'm going to show you how to do it on the calculator too. The way you do it on the calculator, Oops, let's turn on the calculator. Okay, and then we're going to put the equation in, which is x squared minus 4x plus 2. So x squared minus 4x plus 2. Okay, and then we do graph. No, that's kind of out of the screen, so we'll go zoom, zoom, zoom standard, which is 6. That's better. Graph again. Okay, that's better. And so now we've graphed it. Now you can use the calculator to find the vertex by using second calc. Second calc. There we go. And we're going to choose minimum because this is a parabola that opens up, so we want the vertex as the minimum. And so we're going to say, oh, the left bound, we want to mark a point to the left of the vertex. Enter. And now we want to mark a point to the right of the vertex. Make sure it's to the right of the vertex. And then it says, what's your guess? And you could just put whatever there. And then so it says, the answer is 1.9999988 and negative 2. Of course, this is an estimate because the way it does it is an approximation, but you can see this is actually 2.0. So it's x equals 2, y equals negative 2, which is exactly what we got through the other methods. So now we have the turning point or vertex for each of these functions, or for the function a.